A couple things to notice right off the bat in this problem. First, a u substitution isn't going to work out. Second, we have a random -7 in this integral that we can just pull out in front. And third, you can notice that we have this trig sub form here with a equals 4. That means that we're going to use the substitution x equals 4 tangent theta. Taking a derivative gives us dx, and we need to make both of those substitutions to rewrite our integral. I'll replace x with 4 tangent theta, and I'll replace dx with 4 secant squared theta. We can square this term in the denominator. If we do that, we can recognize that, as always, the thing under the square root looks like a trig identity. We can replace tangent squared theta plus 1 with secant squared theta, or in other words, we can replace this whole thing with 16 secant squared theta. As always, at this point, we get a square root of a square, and technically the square root of secant squared is the absolute value of secant. Just like in all of the other trig sub problems, we're just going to assume that secant theta is positive to get rid of those absolute values. That allows us to make the cancellations that we want to make. We're now left with the integral of secant theta d theta. We've seen this final integral in a couple of previous videos, so I'll refer you to those. There's a tricky u substitution that you can do to solve this, or I guess you can look it up in a table. Either way, you get the natural log of secant theta plus tangent theta. And again, we have this answer with thetas in it, but we want x's in our final answer. So to get rid of those thetas, we need to look back at our original substitution. We use the substitution x equals 4 tangent theta, or in other words, tangent of theta equals x over 4. Putting that substitution in this form allows us to draw a reference triangle. If this is our angle down here, then the tangent of that angle needs to be x over 4. And since a tangent is opposite over adjacent, our two sides are going to look like that. Using a Pythagorean theorem, our hypotenuse is going to be the square root of x squared plus 16. Now, rewriting our final answer, we can rewrite secant theta using the reference triangle. Secant is the hypotenuse divided by the adjacent side, and our original substitution gives us what tangent of theta is. Now that is a pretty good answer, but just like in our previous videos, we can rewrite it a little bit. Notice that the two terms inside the natural logarithm have a common denominator, and remember the rule of logarithms. It says that if you have a quotient inside of a logarithm, you can break that logarithm up into two pieces and subtract. Now, distributing the -7 through the parentheses, and if we recognize that 7 times the natural log of 4 is just a constant, and that this c is some unknown constant, if we add a constant to an unknown constant, we get another unknown constant. We could just call that c1 maybe. Doing that is going to give us our most simplified final answer, which looks like this right here. And okay, I think that we're finished with that problem. I'll zoom out so that you can see the whole thing, and we can move on to the next video.